Security controls is a term that you'll find very often in a lot of security trainings, and it basically means a control is something that helps you become more secure. It could be as simple as a guideline or a policy. It could be a rule in the configuration of a firewall. It could be the firewall itself, the box itself. It's something, it could be technical, it could be administrative, it could be anything that helps you improve your security posture. So as a security professional, of course, you need to understand what the potential controls are. And also, when we talk later about security frameworks, you need to understand how those frameworks help you choose the right security controls for your company, for your environment, for your needs. So what do we mean exactly when we say that a security control is supposed to give you more security? Well, it's actually one of three. Right? Remember we talked about CIA triad, the confidentiality, integrity, and availability. Well, we have controls dedicated to increasing the amount of confidentiality, integrity, or availability that they provide to your applications, to your networks, even to your end users. So security controls address one or more of these three pillars of security. So let's see what are the categories of security controls from the perspective of how we're choosing them in order to implement them. And the simplest type of control is the technical control. It could be hardware, it could be software, so it could be a device, a physical box that you're installing in a network. It could be a software solution, a security solution that you're installing on a server or a virtual machine. Or it could just be some piece of configuration that you did not have before, that you chose to implement right now because you've determined that it would improve your security posture. Also, if you think about the hosts, the endpoints, the computers that the employees are working on, technical controls on those computers could be anything ranging from the firewalls or the antivirus that is installed on those devices. And maybe even the fact that you're demanding that every single mobile device in the company has to have some sort of a fingerprint or face ID recognition enabled in order to be accepted in a company. That type of authentication is also a type of technical control. And you're going to find technical controls called logical controls as well, regardless if they're implemented as hardware or as software. The next category are operational controls. These involve the human factor. So this is a way of a control that relies on humans in order to be implemented. It could be a training program for your employees. It could even be the fact that you're educating the front desk staff on how to check or validate the IDs of the people coming into the building. And finally, we have managerial type of controls. These refer to high-level policies, and strictly when talking about security controls, a managerial control is the way that we decide from top-level management on how to choose the rest of the technical and the operational types of controls. How do we decide when to buy a firewall? How do we decide which firewall we'll buy? And how do we decide if we need a firewall or not? That's some type of managerial control. We also have another way of categorizing these controls, and this is by the way that they are designed to help us improve our security posture. So how exactly do they act, and how exactly do they help us improve our security posture? Let me give you a first example. Preventative controls. These are controls that prevent a security incident from happening. It could be anything from a firewall, for example, that doesn't let any traffic initiated from the outside to reach our internal network, which means it's not going to let any attacker attempting to exploit perhaps somebody or a computer inside of our network coming from the outside. It could also be an access list, blocking specific protocols or ports or applications from reaching another segment of the network. Antivirus solutions are preventative as well. They don't allow the execution of a program if they detect malware code in it. So it prevents a security incident from happening. Next category, detective controls. Now, these controls might not stop the incident, but they're going to detect it, they're going to log it, they're going to record as much information as possible, because that's going to help you later on understand what you did wrong, what happened in there, who was affected, how did the attack come to happen, and learn some lessons for the future so that in the future you get a chance to avoid such incidents. A detective control could also be a system that simply alerts when something abnormal happens. It might not need to block the incident from happening at all, but it might be useful to generate an alert so that somebody else, perhaps a human, could intervene and decide whether it's actually a reason for concern or not. Another category are corrective controls. These attempt to correct, to recover after an incident. So they're going to help you bring your system back to a functional state or back to compliance after an unfortunate incident has happened. What's the first thing that comes into mind here? Think about backups. You lost some data, you lost a database, you got a database corrupted, destroyed, you lost perhaps something not just because of a cyber attack, but because, I don't know, the power source failed on a server. Maybe there was a flood in the data center. All right. If you have a backup in place, that's going to be a type of corrective control that's going to help you come back to a functional state from before that incident even happened. Another one is deterrent type of controls. Now, the deterrent controls might not actually prevent the incident from happening, but might discourage potential attackers or potential intruders from actually, performing something malicious. It could be something as simple as a sign that says this is private property. It doesn't have to say that trespassers will be shot, but it's private property, so you will be prosecuted if you are found within this perimeter without proper authorization. It could be a banner on some devices. It could be just lighting over the parking lot, over the building entrance. It could be CCTV or cameras installed in there. It could even be cameras that don't even work because people see that there's a camera in there and they might be discouraged from performing some malicious actions. So that's a deterrent type of control. Funny one is the compensating controls. It's the, at least we have this type of control. It's actually a type of control that we're implementing in a situation where we're not able to implement the controls that we should. So let's say that we are not, we should invest in a new firewall. We don't have the money for it right now. We can only buy that firewall 6 months from now. What we do in between? What do we do until we're able to purchase that firewall? Where we might think about maybe installing some other type of device in there, maybe a router with some firewall functionality, maybe disabling some services that are not critical just to lower our exposure. That's some type of compensating control. If we cannot do what we should be doing, at least we're doing this. And finally, we have physical controls. Don't forget about physical security as well. We're going to have a separate chapter and discussion about those. But physical security means actually those systems, those controls that deny or check or permit access into secure areas of a building. A simple door with a lock can be considered a security control, a physical security control. Again, monitoring, CCTV, guards, even guard dogs, closed doors, authentication using biometrics or RFID cards. Those are all physical security controls. Now, we briefly talked about frameworks a couple of minutes ago, and the reason why frameworks exist is because there's just so much complexity when it comes to securing a company, when securing the network, the servers, the cloud environments, the applications, the computer endpoints, the mobile devices, the building access systems, the physical security, everything else. It's so much complexity in there and so much variety between the offerings of multiple vendors that you're going to run into some analysis paralysis when trying to decide where exactly you should be investing and what exactly you should be purchasing in order to secure a company. So a framework is some sort of a guideline that is going to help us step by step, not only to identify the necessary security items or the security controls that we should be investing in, but also deciding where exactly we are at the current moment. How secure are we? What type of business we have, or what level of security we should be aiming for? And we have a number of such frameworks. Some of them are regulatory, that is, there are some guidelines, specific guidelines that tell you how should you be processing credit card transactions, for example. And it's not just a guideline, it's more than that. It's basically a checklist that if you don't comply with it, you're not allowed to do credit card business. Now, on the other hand, we also have non-regulatory frameworks as well, which basically tell you, well, if you are a small to medium company that deals in this area with these types of services and applications, and you have a network that looks like this, then you should probably invest in something like this. So that's just a guideline in which you get to decide how much you're willing to invest, what type of security solutions you're willing to bring into your environment. But it's not mandatory. It's up to you. And just to mention a couple of these, because you might find them in the exam as well, from NIST, again, the National Institute of Standards and Technology, we can find the Cybersecurity Framework, the CSF. This one is solely focused on IT security, and it's a bit more focused on the US, the United States way of doing things in cybersecurity. Some of these frameworks are more focused on a specific region in the world. Some of them are more international. Also from NIST, we have RMF. That's the Risk Management Framework, which again is focused more on the US, but more on the federal government. And we have FIPS, that's the Federal Information Processing Standards, which is pretty self-explanatory, right? Also developed by NIST. You don't really have to dig so deep within these frameworks. You just have to recognize these names for the exam. That should be more than enough. Then we have the frameworks from ISO, and you're probably recognizing the 27001 standard, because that's one of the standards that a lot of companies nowadays are trying to achieve, and they pay good money for auditors and for a helping hand in gaining this type of certification. Now, from left to right, you don't really need to know about all of these, but we should at least mention them once, just in case you'll encounter them in the exam. So we have 27001, which is the generic security standard when it comes to information technology and information security. Then we have 002, which is about the classification of security controls. We have 017 and 018, which focus on cloud environments and securing cloud applications and cloud infrastructure. And finally, the 27701, the last one here on the list. This is about privacy and ways in which you should or should not be processing personal data. Another one worth mentioning here is the ISO 31K. So while 27K focuses on information security, the 31K focuses on risk management. And since we're in the age of the cloud, we also have the Cloud Security Alliance, or the CSA, which develops a number of frameworks in an attempt to lend a helping hand to cloud service providers those might be public cloud providers such as Google, Amazon, Oracle, and Microsoft, and so on, or smaller cloud providers. So CSA publishes some architectural guides, best practice guides. These are going to be called security guidance. We also have the enterprise reference architecture, which refers to specific tools that are supposed to be used by these cloud service providers. And finally, the Cloud Control Matrix is a publication that tries to list the recommended security solutions, the security products involved in providing cloud services. And finally, and I promise you this is the last one because I know this is boring, we have the SSAE frameworks, which stands for Statements on Standards for Attestation Engagements, which is something that you will never remember, which are just audit specifications for companies that aim to provide some type of hosted services. Hosting data centers, hosting networking equipment, servers or applications or data. It's basically a checklist to prove to the customers ultimately that the provider itself has reached a certain level of professional standards when delivering those services or providing those hosting services. And we have here SOC 2 and 3. SOC stands for Service Organization Control, which is a way to evaluate the controls implemented by the hosting provider itself. So what do they use to protect data or to protect access to the infrastructure that is hosted by them? And we have a number of reports in here. We have the SOC 2 Type 1 report, which it's a way to demonstrate that the design of the system complies with specific standards while the Type 2 report actually focuses on real data, monitored data that shows how those systems have behaved in the last, let's say, 3 or 6 months. So the first one is a more theoretical description. The second one is actually proving that you are complying with those standards. Now, of course, these two types of reports, the SOC Type 1 and Type 2, are most likely private, because they provide a lot of information about the internal infrastructure of that service provider, which should not be public knowledge, because it's going to help potential attackers in developing customized tools to attack that infrastructure. So this is why we also have an SOC 3 type of report, which can be freely published, and it's less detailed, but it addresses the common security concerns of the customers in order for them to sleep soundly at night, knowing that their infrastructure, their data is secured according to best practices and up-to-date security policies. Now, a specific type of frameworks are benchmarks. Now, benchmarks go a little deeper in detail as to how exactly you should be implementing those security solutions described in a high-level overview inside of those frameworks. So the framework tells you how things should look like, while the benchmark actually tells you what you should do or where you're lacking the necessary security controls. Now, one of the most well-known organizations worldwide is the CIS, the Center for Internet Security. They generate benchmarks for security-oriented benchmarks for a lot of products. We have benchmarks focused on validating compliance with specific IT frameworks. We also have benchmarks focused on validating specific configurations on desktop PCs or on servers, on Windows, on Linux, on Mac OS. There's also a CIS benchmark, for example, for Docker. Just to give an example here for the Docker installation. If you don't know exactly how you should be securing Docker, because let's say it's a bit of a newer technology, you've just implemented it in a company, you don't know how to secure it, you run a CIS benchmark in here, and it's going to scan your entire Docker installation. It's going to look for all the configuration items that it can find. It's going to give you a report and a grade, a scored report, telling you this is where you're awesome, this is where some configuration items need attention, and this is where you absolutely suck in the way you've implemented security. You're lacking, for example, encrypted traffic between the Docker client and the Docker server. That's just an example of a report line included in such a CIS benchmark. So it's going to provide you with a huge amount of information, but very addressable, immediately addressable information, because you know exactly what you need to do to increase your security posture. People tend to forget about this one, but vendors, the actual manufacturers of routers, switches, servers, and databases and storage devices and whatnot, they actually develop their own internal security documents and guidelines and design guides to help you secure their own solutions, and they know their solutions best. Right? They know what to advise you, how to advise you in order to learn how you should implement those devices, those products in a secure manner. So don't forget about vendor documentation. They all do it. All the major vendors do it. You just have to search for it. And since the vendor documentation is, of course, vendor specific, we also have some type of documentation that is not so vendor specific. Just to give you two examples here, we have the Department of Defense Cyber Exchange. This one provides some technical guidelines to help you choose the necessary software and hardware configurations in order to better secure your systems, but not focused on a specific vendor. And finally, the National Checklist Program. This one, again, is a benchmark created this time by NIST. We keep running into NIST on every presentation, apparently, which helps you define the current posture and the necessary tasks that you should address for all the major operating systems out there in the market. And I know I'm repeating myself, but don't forget that every time you talk about infrastructure, you should address the cloud infrastructure as well. So it's not enough just to physically secure or logically secure your own data center if some of your applications are actually running in somebody else's data center, like in a public cloud. That's a completely different way of managing things in there. It's a completely different architecture, different infrastructure. You don't have that much control over the low-level part of that infrastructure, so you need to address security completely different when you go from on-prem to the cloud. Just remember this. Now, the benchmarks and frameworks, of course, take this into consideration. You just have to don't forget that there's also a cloud part of your infrastructure that needs some TLC. And finally, don't forget about applications, because we've talked about securing environments, infrastructure, devices, and so on. But at the end of the day, all that infrastructure is there to serve code, to serve applications, right? So the way the applications are developed and the way the applications are secured, more or less, is going to have a big impact on your overall security posture. That's why many benchmarks and many frameworks actually address not the infrastructure on which the application is running, but the application code itself. And of course, since nowadays we have such a wide variety of applications, we have specific benchmarks and tools and guidelines to help us for determining the software flaws and software issues that might arrive from a badly configured application for web applications, for mobile applications, and even for microservices applications running in containers, managed perhaps or scaled by something like Kubernetes. And since we mentioned at the beginning of this episode that there are frameworks on the more mandatory side, well, here they are. They're called standards and regulations. You have to abide by these regulations if you plan on doing business in a specific territory with a specific type of data or interacting with a specific entity, special governmental entities. So just a brief glance over the major ones here. We have GDPR, General Data Protection Regulation, widely known in Europe and European Union, which is strongly focused on privacy and protecting personally identifiable information. We also have the GLBA, the Ground-Leach-Bailey Act, for financial institutions. Sarbanes-Oxley, or SOX, makes sure that all the companies, major companies at least, properly implement things such as selecting security controls, performing risk assessments, and so on. Next up, we have the Computer Security Act, which requires federal institutions to have proper security policies for any system that processes private or confidential information. FISMA, the Federal Information Security Management Act, again pretty self-explanatory, addressing federal government. HIPAA includes a number of procedures and policies that dictate how medical records should be processed and how patient information is supposed to be transferred, stored, for how long, how it should be secured. CCPA is the California Consumer Privacy Act, pretty similar to GDPR, but it's one example of a regulation that applies only to a single state, like California. And finally, PCI DSS, focused on credit card transaction and any kind of institution or company that processes payments using credit cards. Of course, you do need to have some sort of infrastructure, well-secured infrastructure in place in order to be part of an entire system that processes credit cards. So that's why we have a specific regulation that addresses this specific use case. It stands for the Payment Card Industry Data Security Standard. All right, that's it about frameworks and benchmarks. If you like this, leave a comment, like and subscribe, and see you on the next video. Bye-bye.